Hi, this is Mr. Shumway. This is a quick video clip about electricity. Voltage, resistance, and current are the three basics. Voltage can be compared to how high a waterfall is. Current can be compared to how much water is flowing in a river going over the waterfall, for example. And resistance is kind of like friction. It's trying to slow things down. Voltage is equal to the current times the resistance. Okay, so if we have a 12-volt car battery and a 6-ohm light, how much current would flow? Well, we know that the voltage is equal to the current times the resistance. So if we wanted to find the current, we would solve for I, divide both sides by R. So the current is equal to the voltage divided by the resistance. Well, we know the voltage is 12. Resistance is 6 ohms. That gives us a current of 2 amps. The sign for ohms is like that. 12 volts divided by 6 ohms, 2 amps flow. So the resistor, the light acts as a resistor. It tries to slow down the flow of electricity. If you just put a straight wire across a battery, electricity flows very fast. But a light slows it down. So let's say you have 2 amps of current flow through a 60 ohm light. How many volts does the potential drop across the light? The potential is like, when we're talking about potential energy, something can drop. When we compare voltage to something falling, how far it falls, that's a good comparison. So we know that the voltage is equal to the current times the resistance, and we have both those. So we say 2 amps times 60 ohms. Well, that gives us 120 volts. Maybe I ought to write the symbols for those. We often write a battery like that, with maybe a plus here and a minus there or something, and then we'll run it through a resistor. We make a little squiggle, and so this is the resistor. This is the battery. And we draw the wire through which the current flows, just with a line. So that's our basic formula that you probably need to memorize. Voltage is equal to the current times the resistance.